Okay, we're almost at the end of Chapter 2, but before we leave it, let's think back on the ticket machine. Let's make it a little bit better. You can either open up the Better Ticket Machine example from the chapter2.zip, or you can think about how you would write it yourself. So, if you remember from the earlier videos, the early ticket machine would print a ticket if we didn't enter enough information. It didn't offer a refund if we put in too much money. And there was just no checks in the constructor to make sure that it was actually a ticket machine that wouldn't spew out money instead of take in money. So in order to be able to do better, we need to be able to make decisions. We have to be able to choose two different paths. And so this is just a quick review of how the if and if-else statements will work. We make decisions all the time, you know. If we have money left in our budget, we can go out for a meal, although it should be takeout. Otherwise, I will stay home and watch a movie. If the pandemic is still a major threat, I will weigh the options that are before me and then make some decisions based on the likely risk that I might face, just to make it a little bit more timely. Well, if we're going to do things like that in Java, we would use the if statement. Now, remember, ifs don't have to have elses. So we could just do it. If this is true, we'll do something, otherwise we do nothing. But often we need to go back and forth between two separate options. If something is true, we will do one option, else we will do some other option. And if that's the case, then we have this sort of setup. The basic structure, again, is the if keyword in lowercase, a set of parentheses with some condition. We call these Boolean conditions. They have to evaluate down to true or false. We'll talk a little bit about kind of how computers deal with true or false in a separate supplemental video, because it's not necessarily as straightforward as you might think. Then we have curly braces to indicate a block. Then that's what happens if the test is true. Then we have an else statement, another set of curly braces, and the statements that get done if the test is false. I'm going to take a side trip here, and I'm going to ask you to consider this question. How many statements can appear after an if? Or how many statements can appear after an else? Pause this for a second. Think about it. And when you have the answer, continue the video. Okay, welcome back. I don't know if this is going to work, but I'm going to do this on the fly. Just want to insert a new blank slide here. The question I asked is how many statements can exist after an if, and this is actually after any statement, not just an if statement, but after a while, after a for statement, for loop. And the answer may surprise you. You're only allowed to have one statement after an if or other keyword. And you might say, well, that can't be true, Professor Crosby. I mean, I know I've done things like if x is less than 10, curly brace, that's a big tab, system.out.print, here is a statement. And just in the interest of time, here is another statement. And just for fun, liar! Close. And you'd be right for thinking, well, yeah, there's actually all of these statements after the if. But I want you to keep in mind something important. There really is only one statement after the if, and it's a statement that is defined by it opens with a curly brace and closes with a closing curly brace. This thing right here is called a block statement. By definition, a block statement begins with a curly brace, and then any other number of valid statements inside of it, and then it has to end with a matching curly brace. So this all right here is the one statement that's after the if. Now, why is this important? It is perfectly legitimate if you have a simple if statement to not have a curly brace. So you could have something that's like this. If, don't capitalize O. And I apologize. PowerPoint is trying to make me English instead of programming. If y is equal to z, then a equals b plus c. In this case, there is just one statement after the if, but if I then realize I need to do something else, if a equals b plus c and d equals e minus f, my indenting may make me think that both of these statements will be run, but in reality what's going to happen, whoops, it's not letting me select. So frustrating. This is much easier when I do it on a whiteboard. Because Java only cares about the curly braces, not about the indenting. Now, you Python people now might understand why Python requires indenting to indicate blocks, because the visuals match what the computer sees. But for us, if we have the top, if y equals z, do both of these things, the reality is only the first one gets done. And this statement, because it is not the one statement after the if, will always be done. So even though in this example there might only be one line in here, I recommend always using the curly braces, because if you go back in and decide that you need to add some additional things to happen on that condition, you don't run the risk of accidentally introducing a bug in your program, because it will still compile. It just doesn't mean what you think it means. You know, the visual of the indent doesn't align with how the computer is going to follow the logic. Okay, so let's make a choice with the ticket machine. When we insert money, let's first make sure that when we insert money that we're not pulling money out. So if the amount is greater than 0, then we add it to the balance. If the amount is 0 or less than 0, then we'll print out, use a positive amount. The amount you gave was this. And this means that we are not able to extract money from the machine and take money away from the balance, which is a pretty good thing. I mean, if you're the owner of the machine anyway. Now, let's take a look at variables. Let's just reconsider. Remember that some variables we give special names to. So fields are a type of variable. They're the variables that store values that exist for as long as the object is in existence in your Java program. So we call that the lifetime of the object. The other thing about fields is that because they're defined with the scope of the entire class, they're accessible to every method without having to pass them around. They are just part of the object that any method can reference. So fields, one type of variable. Parameters are another type of variable. These are used to pass specific information into a method so the method can do its job. So in the header of the method, we define the data type and the name that we're going to give that parameter, and then we can reference that parameter as a variable inside the method. Every time we call that method, we can change the value of the parameters that we send in. So, for example, at the end of the semester, there might be a loop that goes through all of the G numbers of people in this class, and I will pass in a different grade for all of you, depending on what grade you earn over the course of this class. So one more comparison between fields and parameters. Fields their lifetime is the entire lifetime of the object. For a parameter, they only live as long as that method is doing its job. As soon as you exit the method, those parameters disappear. I'm sorry, the values for the parameters disappear. The variables still exist for the next time the object is invoked. Now, with this in mind, it's time to introduce a third type of variable. But before we get there, let's just refresh the idea that one of the things that BlueJ does as an IDE that honestly might be a little off-putting to people who have already internalized the fact that curly braces are important. What BlueJ does is it uses colors and blocks to indicate where your curly braces open and close. So the large green area that spans this window is the class. Here, the definition of print ticket plus its header comment, this yellow block, is the scope of the print ticket method. Inside, the scope of the body of the method is represented between these curly braces by this gray block. Inside of the gray block, we have another set of curly braces to make a block statement for our if. So this white box is what happens if the true condition is met, and this other white box is what happens if the false condition is met. One of the things that effective programmers ultimately do is they internalize the ability to recognize the opening and closing curly braces, but it is not always obvious. If you have a particularly complex method, you may have 6, 7, a dozen open curly braces that have to be opened and closed. And I still find myself as a programmer with 30 plus years of experience now, using my hands. I start with a fist, and every open curly brace I raise a finger, and every closed curly brace I put the finger back down. So it's like, if I'm looking at print ticket, open, my thumb goes up. If balance equals price, index finger goes up. Close the if, index finger goes down. Else, open, index finger goes up. Else, close, index finger goes down. Close print ticket, I'm left with a fist. Now here, the entire scope of the method is visible on screen, so I should be able to see the open and close. If the method is longer, though, this kind of manual check is something that I still fall back on, even though modern IDEs will often have a match curly brace or even reformat to make sure that all the indenting lines up to make it a little bit more obvious. Just keep in mind that BlueJ is going to give us this scope highlighting. Okay, so curly braces define blocks. Each block defines a new scope. So you can have class scope, you can have method scope, you can even have statement scope. Scopes have to be completely nested. They can't overlap. One has to open and then close. They're like nesting dolls. They can't clip through the outside shell. So as long as everything is completely inside of another, everything is okay. So the scope is also defined in the source code in the text. Compare that to the lifetime, which is what's happening at runtime. So lifetime of an object or lifetime of a variable depends on how long that object exists in memory. So with scope and lifetime defined, let's try to think about how we would refund extra money that was put in. You might be tempted to say, okay, we're going to refund the balance. So the name of our method is refund balance. We'll return the balance that's back, and then after we return, we'll set balance to 0. Now, that looks like it should work, but you should realize that a return statement means leave the method, do not pass go, do not collect $200. We leave at this point, boom. This line is never reachable, and the compiler will say that there are statements that are unreachable and won't let you do this. But if we set the balance earlier, now we've taken the money away and we can't return it. So we have to store some information for the short term. That leads us to the idea of local variables. A local variable is the third type of variable we're seeing in this chapter. So these are like little pieces of scratchpad. Like next to my computer right now, I've got a series of post-it notes, just places where I can put short, small pieces of information that aren't critical to get into long-term, but I need that information right now. So while a parameter lives through the entire method, a local variable might only live for a part of the method, inside the block in which it's defined. It's going to be the method's job to establish their values, and they're not coming from the outside. They're things that the method is going to create on the basis of information it's been given. So local variables will only exist within the method. They'll even only list within a block within the method, and they're only defined and accessible at that point. So let's look at how this might look in practice. Refund balance. Because refund balance is a method that is pretty tight, it's all happening inside of one block. So we need to have a temporary integer. So we'll declare it as an integer. We don't have to give it public or private. We'll name it amount to refund. And then we'll say, take the value that's in the field balance, tuck it onto this temporary space, reset the balance to 0, then go and look at that temporary space and use that value to return it back to the end user. Just keep in mind, statements are always executed in sequence. That is the way a computer wants to operate, because that's the way the underlying electronics work. And so we have to take into account this kind of take some temporary space to store some information in order to be able to use it later. This is a fairly common pattern of statements. So just to try to put a bow on this, thinking about fields, its scope is the entire class. Every method has access to it. And its lifetime is as long as the object is in existence. The scope of a local variable is the block in which it is declared. And the lifetime of a local variable is the time of execution of the block in which it is declared. I'm going to see if I can get BlueJ up and running on here. I'm going to make a new class and call it scope demo. Now, the thing about this is that it is important to see how scope works. So I'm going to keep this this field X, and on the constructor X will be assigned a value. And I'm going to have a method called demonstrate scope with no parameters, and it is going to return void, because I'm just going to do some printlns and some declarations. So system.out.println x colon plus x. I'm going to make this one the field. And then I'm going to try something silly. I don't know that this is going to work. I'm going to declare a local variable x. Int x equals 42. And then I want to print out local. Let me see if this compiles. Errors found in class. It doesn't like the fact I forgot my semicolon. But now it compiles. Now this is a concern, right? I've got a variable named x which is local. I've got a field named x which has a scope of the entire class. Are they going to run into each other? Well, let me make an object of type scope. Here's my scope object. Let me demonstrate scope. The field value of x when it prints out is 0. The local variable when it prints out is 42. But that local variable does not change the field. That local variable, my object, still has a field value of 0. Because those two values, those two variables are different from each other. Weird, right? I could do something like this and say this object's x field equals 37. If I compile this and run scope demo and tell it to demonstrate scope, it means, oh wait, BlueJ already has this window open somewhere. View terminal. Okay, so it printed this again, but now I can see that the field has changed because down here I said this object's field named x takes on a new value. Okay, so we can have two things with the same name. Because they're scoped differently, they have different meanings. I'm going to take away this line. I'm going to do something even weirder. I'm just going to arbitrarily start a block, because I can do that. And in here I'm going to say int x equals 1000. And local inner block. Then I'm going to come back out here. Local outer block. And fortunately, in this case, it doesn't let me do that because it says x is already defined in my scope. Thank goodness. But keep in mind that in C and other or C++, you can actually redefine a variable farther in the scope. So this scope, because x exists and this scope is inside of this scope, it doesn't allow us to reinitialize it. It doesn't allow us to redefine it. I can change it. So if I don't declare x as an int and I compile, let me get my terminal up and tell the terminal to clear itself so we don't have old information in it. Demonstrate scope. So the field stays at 0. We assign it to 42. It prints out 42. We reassign it to 1000, but because this variable x is this variable x, when we leave that value has changed. But just keep in mind that your scope allows us to have variables with the same name as our fields, and they are actually different variables. Okay, let's review. Classes define the object. They contain fields, and the fields are going to be variables that allow us to store information about that object. They have constructors that initialize the values for those fields. They have methods that indicate what that object is capable of performing. This is actually really important. We use different names for variables because they have different contexts. Get in the habit of using the proper, more narrow identifier. If you're talking about something that belongs to the class, say that it is a field, but understand that that is a variable. If it's something that's being passed to a method, say that it is a parameter, but keep in mind that it's a variable. If it's something that you're defining locally so the method can do its work, call it a local variable. Keep in mind that each of these objects or each of these values lives for a different length of time. Fields will be available as long as the object is in memory. Local variables only exist as long as the variable is in scope, and parameters are useful for the entire invocation of that method and are ways to put values into constructors or methods. Thinking about methods, all methods have a return type. Constructors are a special type of method, if you will, that return an object of the class that we're making, but other methods need to be told that either void, I don't return anything, but it's still a return type, or it's some other variable type, and it doesn't have to be a primitive. We're going to be spending our time returning very complex objects across objects from one object to another so that they can do more difficult tasks for us. If the return type is not void, there must be a return statement. Okay, so there has to be a return value, there has to be something to return, and we have to explicitly return it in that return statement. And finally, a lot of programming is getting used to controlling the flow of code through a series of statements. Sometimes we need to choose one path over the other. Sometimes we need to repeat a statement over and over. We're going to look at that in more detail. Keeping in mind from the History of Languages lecture, these programming languages have common ancestors, which means that if you can keep in mind that there's this certain pattern of how to control the flow of information, you'll be able to understand many more programming languages more quickly after you get one under your belt, because it'll just be, oh, I need to make a decision here. These are the kinds of things that decisions can be. Let me rephrase that. I need to make a decision here that makes a decision and continues moving forward through the sequence. Or I need to make a decision here that's going to allow me to go back and repeat a sequence. It's not that you're making a decision that's the important thing. It's, am I making a decision and continuing through the sequence as it appears? Or am I making a decision that's going to allow me to go back and do the same set of statements more than once? And we'll have another lecture about that later. All of those things have Boolean tests which will result in either true or false. And these true or false results will then determine whether or not these additional code flow statements take effect. Okay, you've held on for a rather lengthy chapter. I wish I could say they get shorter after this, but go build an object with a book. Let's see what you can do, and I'll see you in the next set of lectures.